Efficient wiring techniques for large homes can lead to significant cost savings. Firstly, consider bulk purchasing. Negotiate discounts on materials with suppliers by purchasing in bulk. Consider joining buying groups or cooperatives for additional savings. Secondly, think about centralized distribution. Establish a central location within the home to distribute wires and materials to crews. This reduces unnecessary movement and wastage. Thirdly, employ optimized wire routing. Plan wire paths strategically to minimize bends and excessive length. Utilize existing structures and spaces for wire runs, such as joists, walls, and attics. Fourthly, explore shared neutrals. Use shared neutrals for single-pole devices such as switches and receptacles that are on the same circuit and located close together. This eliminates the need for a separate neutral wire, saving on materials and labor. Verify local code requirements for shared neutral applications. Fifthly, utilize multi-wire branch circuits, also known as MWBCs, for loads that can share a common neutral. This allows the use of few circuits, reducing the number of circuit breakers required. Sixthly, focus on panel distribution. Distribute circuits evenly across multiple panels to balance the load and reduce the risk of overloads. Consider grouping similar loads on individual circuits, for example, lighting, outlets, and heating, ventilation, and air conditioning. Seventhly, remember labor optimization. Assign specific tasks to crews and rotate them regularly to maintain efficiency. Provide clear instructions and training to ensure proper execution. Use labor-saving tools and equipment such as wire strippers, crimpers, and fish tapes. Eighthly, investigate technology integration. Consider implementing smart home technology such as smart switches and dimmers. This can reduce wire runs by eliminating the need for additional switches or dimming modules. Other important tips include using color-coded wires to identify circuits and simplify troubleshooting. Label wire bundles and panels clearly for easy identification. Maintain a clean work site to avoid damaging wires or creating hazards. Regularly review codes and industry best practices to ensure compliance and efficiency. By implementing these strategies, you can optimize your wiring procedures, reduce costs, and improve overall efficiency on large home electrical projects. Careful planning and attention to detail can lead to significant savings in both materials and labor. For example, when running Romex, also known as non-metallic sheath cable, through wooden studs, ensure that the holes are drilled in the center to provide adequate protection from nails or screws that may be driven into the wall in the future. When making connections in junction boxes, be sure to leave enough wire length for future modifications or repairs. A minimum of 6 inches extending from the box is generally recommended. Secure all cables properly with cable staples within 12 inches of boxes and at intervals not exceeding 4.5 feet along the run. This prevents strain on connections and protects the cables from damage. Use appropriately sized wire connectors for all splices and terminations, ensuring that they are properly tightened to provide a secure and reliable connection. Consider using push-in connectors for quick and easy connections, but ensure they are rated for the wire gauge and application. When installing electrical boxes, ensure they are securely mounted to studs or other structural members. Use appropriate screws or nails for the mounting method. Level the boxes properly to ensure that devices such as switches and receptacles sit flush with the wall surface. When working with metal boxes, use grounding bushings and bonding jumpers to ensure proper grounding of the box and connected equipment. This helps to prevent electrical shock hazards. When installing recessed lighting, ensure that the fixtures are rated for insulation contact, also known as IC rated, if they will be in contact with insulation. Follow the manufacturer's instructions for proper installation and wiring. When running circuits for specific appliances such as dishwashers or garbage disposals, ensure that the wiring is properly sized and protected by a dedicated circuit breaker. Follow the National Electrical Code, also known as NEC, requirements for appliance circuits. When installing ground fault circuit interrupters, also known as GFCIs, in areas such as bathrooms and kitchens, test them regularly to ensure they are functioning properly. Replace any faulty GFCIs immediately. When working with low-voltage wiring, such as for thermostats or doorbells, use appropriate low-voltage cables and connectors. Keep low-voltage wiring separate from high-voltage wiring to prevent interference. When installing home automation systems, plan the wiring layout carefully to accommodate the various devices and controllers. Use a structured wiring panel to centralize the connections and make future modifications easier. When wiring outdoor lighting, use weatherproof fixtures and wiring methods. Protect the wiring from moisture and physical damage. Consider using photocells or timers to control outdoor lighting automatically. When installing electric vehicle charging stations, follow the NEC requirements for electric vehicle supply equipment. Use appropriately sized wiring and overcurrent protection. Consult with a qualified electrician for proper installation. When wiring for generators, use a transfer switch to safely switch between utility power and generator power. This prevents backfeeding into the utility grid, which can be dangerous. Follow the NEC requirements for generator installations. When performing any electrical work, always turn off the power at the circuit breaker before starting. Use a voltage tester to verify that the power is off before touching any wires or terminals. Wear appropriate personal protective equipment, such as safety glasses and gloves, to protect yourself from electrical hazards. Always follow the NEC and local electrical codes when performing electrical work. Obtain necessary permits and inspections to ensure compliance. If you are not comfortable performing electrical work yourself, hire a qualified electrician to do the job. Electricity can be dangerous, and it is important to work safely and correctly. Remember to always prioritize safety when working with electricity. Taking the necessary precautions can help prevent accidents and ensure that the electrical system is installed properly and safely. Consider energy-efficient lighting options such as light-emitting diodes, also known as LED, to reduce energy consumption and save money on electricity bills. LED use significantly less energy than incandescent or fluorescent lights and have a longer lifespan. When selecting wiring devices such as switches and receptacles, choose high-quality products that are durable and reliable. Look for products that are listed by a recognized testing laboratory such as Underwriters Laboratories, also known as UL. Use surge protectors to protect sensitive electronic equipment from voltage spikes and surges. Surge protectors can help prevent damage to computers, televisions, and other devices. When wiring a home theater system, plan the wiring layout carefully to accommodate the various components and speakers. Use shielded cables to minimize interference and ensure good sound quality. When wiring a security system, follow the manufacturer's instructions for proper installation and wiring. Use tamper-resistant screws to secure the control panel and other components. When wiring a fire alarm system, follow the NEC and National Fire Protection Association, also known as NFPA, requirements for fire alarm systems. Use heat detectors in areas such as kitchens and garages where smoke detectors may not be appropriate. When wiring a telephone system, use appropriate telephone cables and connectors. Keep telephone wiring separate from power wiring to prevent interference. When wiring a data network, use Category 5 or Category 6 cables and connectors. Follow the Telecommunications Industry Association, also known as TIA, standards for data network wiring. When wiring a cable television system, use coaxial cables and connectors. Follow the Society of Cable Telecommunications Engineers, also known as SCTE, standards for cable television wiring. When wiring a satellite television system, use RG-6 coaxial cables and connectors. Follow the satellite television provider's instructions for proper installation and wiring. When wiring a public address system, use shielded cables to minimize interference and ensure good sound quality. Follow the manufacturer's instructions for proper installation and wiring. When wiring a nurse call system, follow the NEC and NFPA requirements for nurse call system. Use appropriate call buttons and indicator lights. When wiring a lighting control system, plan the wiring layout carefully to accommodate the various dimmers and controllers. Use a central control panel to manage the lighting system. When wiring a building management system, follow the manufacturer's instructions for proper installation and wiring. Use sensors and controllers to monitor and control various building systems such as lighting, heating, and cooling. Consider the use of conduit for protecting wires in exposed or hazardous locations. Conduit provides physical protection for the wires and can also prevent electrical shock hazards. Use appropriate fittings and connectors for the type of conduit being used. When running conduit through walls or floors, ensure that the holes are properly sealed to prevent the spread of fire or smoke. Use fire-rated sealant to seal the holes. When installing grounding electrodes, follow the NEC requirements for grounding electrode systems. Use appropriate grounding rods, plates, or other grounding electrodes. Ensure that the grounding electrodes are properly bonded together. When installing surge protective devices, follow the NEC requirements for surge protective devices. Use appropriate surge protective devices for the type of equipment being protected. Ensure that the surge protective devices are properly grounded. When installing arc fault circuit interrupters, also known as FSIs, in bedrooms and other areas, test them regularly to ensure they are functioning properly. Replace any faulty FSIs immediately. FSIs are designed to protect against electrical fires caused by arc faults. When installing tamper-resistant receptacles in homes with children, ensure that the receptacles are properly installed and functioning. Tamper-resistant receptacles have internal shutters that prevent children from inserting objects into the slots. Remember to consult the latest edition of the NEC for the most up-to-date requirements for electrical installations. The NEC is updated every 3 years, so it is important to stay current with the latest changes. Consider attending electrical training courses or seminars to improve your knowledge and skills. Electrical training can help you stay up to date with the latest technologies and techniques. When troubleshooting electrical problems, use a systematic approach to identify the cause of the problem. Start by checking the circuit breaker or fuse. Then check the wiring and connections. Use a multimeter to test for voltage and continuity. When making electrical repairs, always use the proper tools and materials. Use insulated tools to protect yourself from electrical shock hazards. Use wire connectors that are rated for the wire gauge and application. When replacing electrical devices, use devices that are rated for the voltage and amperage of the circuit. When working on electrical systems in older homes, be aware of potential hazards such as asbestos wiring and lead paint. Take appropriate precautions to protect yourself from these hazards. Consider hiring a qualified electrician to perform electrical work in older homes. Remember that electrical work can be dangerous, and it is important to work safely and correctly. If you are not comfortable performing electrical work yourself, hire a qualified electrician to do the job. Electricity is a powerful force, and it is important to respect it. Taking the necessary precautions can help prevent accidents and ensure that the electrical system is installed properly and safely. Use appropriate wire sizes for the amperage of the circuits. Refer to NEC Table 310.13b16 for allowable ampacities of insulated conductors. Use larger wire sizes for longer runs to minimize voltage drop. Consider using aluminum wire for larger feeders and branch circuits. Aluminum wire is less expensive than copper wire, but it requires special connectors and installation techniques. Use antioxidant compound on aluminum wire connections to prevent corrosion. Torque all electrical connections to the manufacturer's specifications. Use a torque wrench to ensure that the connections are properly tightened. Over-tightening or under-tightening connections can lead to overheating and failure. Use appropriate labeling for all electrical panels and circuits. Clearly label each circuit breaker with the loads it serves. Use arc flash labels to warn of potential arc flash hazards. Provide adequate working clearance around electrical equipment. Follow NEC Section 110.26 for working space requirements. Ensure that there is sufficient space to safely access and work on electrical equipment. Use ground fault protection for equipment. Ground fault protection can help prevent electrical shock hazards and equipment damage. Follow NEC Section 215.9 and 230.95 for ground fault protection requirements. Use surge arresters to protect electrical equipment from voltage surges. Surge arresters can help prevent damage to motors, transformers, and other sensitive equipment. Follow NEC Section 280.4 for surge arrestor requirements. Use harmonic filters to reduce harmonic distortion in electrical systems. Harmonic distortion can cause overheating and equipment malfunction. Consider using energy-efficient transformers to reduce energy losses. Energy-efficient transformers have lower core losses and can save money on electricity bills. Use power factor correction capacitors to improve the power factor of electrical systems. Low power factor can increase energy losses and reduce system capacity. Use variable frequency drives, also known as VFD, to control the speed of motors. VFD can save energy by reducing the speed of motors when they are not needed to run at full speed. Use programmable logic controllers, also known as PLC, to automate electrical systems. PLC can be used to control lighting, heating, ventilation, and other building systems. Use supervisory control and data acquisition, also known as SCADA, systems to monitor and control electrical systems remotely. SCADA systems can provide real-time data on system performance and allow for remote control of equipment. Regularly inspect and maintain electrical equipment. Check for loose connections, damaged wiring, and other potential problems. Perform preventive maintenance to prevent equipment failures. Keep electrical equipment clean and free of dust and debris. Dust and debris can cause overheating and equipment malfunction. Train employees on electrical safety procedures. Ensure that employees are aware of the potential hazards of electricity and how to work safely around electrical equipment. Provide employees with appropriate personal protective equipment. Use lockout/tagout procedures to energize electrical equipment before performing maintenance or repairs. Lockout/tagout procedures can help prevent accidental energization of equipment. Follow all applicable safety regulations and standards. Comply with the requirements of the Occupational Safety and Health Administration, also known as OSHA, and other regulatory agencies. Stay up to date on the latest electrical technologies and best practices. Attend industry conferences and seminars to learn about new developments in the electrical field. Read trade publications and technical journals to stay informed about current trends and technologies. By following these tips and best practices, you can ensure that electrical systems are installed and maintained safely and efficiently. The electrical safety is a critical concern, and it is important to take all necessary precautions to protect yourself and others from electrical hazards.